Hello and welcome to this video on the setup of the EKS cluster for the cSRX. I'm Mithun Hebar, product lead in the security group at Juniper Networks. In this video, I'm going to walk you through bringing up a setup for deploying the cSRX in a Kubernetes cluster in Elastic Kubernetes Service in AWS. I will be using a README file that is present on the GitHub location mentioned on the slide. The steps in this demo would be the following. Bring up a Kubernetes cluster first. Then we're going to set up the worker nodes in the cluster. Following that, we'll install the Multus CNI and set up the Flannel network. Then we create the IAM service account for the pods in the cluster. And finally, we'll set up the web application services and cSRX service in EKS. I begin with creating or renewing my SAML credentials. I do that using a Python script that is available in GitHub at the location provided. That script fetches the credentials for a Juniper account. It can be modified to suit your needs. These SAML credentials are used to interact with the Kubernetes cluster that we will be deploying in EKS. You'll see here that I already have EKSCTL installed on my computer. I go ahead and create a cluster in EKS using the EKSCTL create cluster command, passing my SAML credentials as a parameter. This command creates a CloudFormation template which can be seen from the GUI. From the console. The CFT sets up the managed Kubernetes cluster with the associated policies, route tables, and control plane for the cluster. It takes a little time to complete the creation of the cluster, and I am going to fast forward to the point where it has been created. You can see here that on the right side of the screen, I have the README file open from the GitHub location where the deployment scripts are available. You can see in the console here that the CloudFormation template has completed. Okay, now that the cluster has been created, the next step we take is to delete the AWS node that was created as part of the cluster creation. This removes the AWS CNI, that is the default CNI created in EKS. We will be using the Flannel CNI with Multus to deploy the cSRX in this cluster. Next, we create a node group with the parameters specified in the EKS cSRX demo cluster.yaml file. This YAML file is in the GitHub repo for the cSRX scripts deployment. It contains the EC2 instance type to be used among many other parameters. In this demo, we will be using the t3.medium EC2 instance for the worker nodes. This task also creates a CloudFormation template and typically takes at least 30 minutes. I'm going to fast forward through this section as well to the next step, which is to install the etcd pod. In that etcd pod created in Kubernetes, we need to set the network and subnet length. We do that using the highlighted text in the README file. Then we install the Multus CNI and modified the etcd IP in the kubeflannel.yaml file with the IP address that is assigned to the etcd pod. If you look at the state of the pods in Kubernetes, we'll see that the etcd pod is now running with the IP address ending in 128. Now, I go ahead and edit the file, replacing the etcd endpoints with the IP address assigned to etcd by Kubernetes. You'll notice that I made a typo there. I entered the wrong IP for etcd, typing in .129 in place of .128. We'll see the effect this has on the deployment later on in the video. Next, we confirm that the cluster is created in our account, and we now associate the IAM role with the cluster that we just created. Now, we are done with the initial cluster deployment and CNI installation. I now move forward to preparing the setup for the use cases that we target with the cSRX. You'll see here that there are different YAML files in this folder, and we go ahead and apply all of them using the kubectl apply command. Okay. Next, I create the IAM service account for the cSRX pod. Next, I download and install the metric server in Kubernetes in the demo cSRX cluster created. For this demo, I have created a web service. Now, the IP address of the web service needs to be updated in the cSRX config so the source NAT happens correctly and the container firewall is able to forward the traffic to the intended destination. To do this, I use the web service IP from the Kubernetes get service output. In this demo, I use the set command highlighted in the README section on the right side of the screen. However, that does not always work. I recommend you ensuring the cmpg.yaml files are checked for the correct IP address being updated prior to deployment of the use cases. Now I go ahead and attempt the first use case. I apply the files in the folder 1 North South Nginx Ingress Controller. We see that there are two nodes in the cluster. As a README file states, I need to log into each of these worker nodes and run the ifconfig command that will ensure the traffic is forwarded to the web service from the cSRX through the bridge that has been configured on these worker nodes. To log into the worker nodes, I move to the AWS console and retrieve the public IP address of the worker nodes. I SSH to the first worker node using the key that I had specified in the EKS cSRX demo cluster.yaml file at the beginning. I configure the BR51 interface with the IP address 51.0.0.1/24. Now, I do that on both the nodes. Now, if you look at all the assets created in our cluster, you will see that the core DNS pods in the kube system namespace are still in the container creating status. The same is the case with the metric server pod. We see that etcd is running. However, the IP address that we had configured in the Kubernetes flannel.yaml file was wrong. And that has resulted in the core DNS pods not coming online, following which even the cSRX pods are not coming online. So now I would have to go in and fix that IP address for the etcd endpoint and apply kubeflannel.yaml again. Voila! We'll see now that the core DNS pods have moved to the running state. And shortly, if you look for our cSRX pods in the default namespace, we see that those are up and running as well. We are now ready to proceed with deploying the other use cases and showcasing the capabilities of the cSRX as a North-South firewall. Thank you for watching this section of the cSRX deployment on EKS. In this section, we saw how we can set up the cluster and bring up the cSRX as a service along with the web service applications. Thanks for watching.